and sharing the screen. And I'm going to admit that I was lazy today and I didn't create a new OneNote for today, but rather I'm just adding on to where we left off. Before we get there, let's go back to that first page. Homework 5 should be, hopefully for everybody, 5.2 should be water under the bridge. Homework 5.8 should be water under the bridge. Problem set 4 and test 4, those have gone. So what's left is the problem set final that is due by the end of the day tomorrow, and the optional final, which needs to be done by the end of the day on Thursday. Today's the last day we're taking attendance. Attendance will be optional on Thursday. I will have Zoom open. If nobody shows up, probably not for the first 2 hours. I'm not going to necessarily take attendance and have class then, because I know some of you have pretty tightly packed lives, and so you might want that 2-hour period of class time on Thursday to take the final if you had not taken it yet. The My Math Lab, I went through since the weekend. I went through yesterday, and I looked at anything that was submitted late, and any question where you were given less than half credit for what you submitted. I adjusted the grade, and then I dropped the 3 lowest grades and put that average for my labs in Blackboard. So the My Labs average in Blackboard should be accurate. Everybody who took test 4 is in Blackboard. So look at that, look at your tests, and see, decide whether you want to take the final or not. If you're happy with your grade, which I would think would be anybody who doesn't have a lot of zeros in there that's working on an A right now, you might not want to take the final. Other folks taking the final might be what you need to bring your grade up. Excuse me. Does anybody have questions about any of that? Again, the 2 things that we need to look at is the problem set final should be done by the end of the day tomorrow, and the final exam should be done by the end of the day on Thursday. The problem set final, there's a column for that in the Blackboard grade book, because that counts as a quiz grade. Again, with the problem sets, I don't look at your work because you can take them over and over and over again. But with the final exam, make sure you submit your work in Blackboard, no matter what grade you get, because I do look at the work to make sure, first of all, that you did the work, and second of all, to look for any partial credit that I might get. Any questions on any of that, folks?
I think I might have misheard you. Did you say you already dropped a test grade?
No, I did not already drop a test grade. I'm not going to drop a test grade if the final exam is in there, because the test grade will only get dropped if you take the final exam. So thank you for reminding me of this fact. If you do not take the final exam, do not panic when you see that there is a 0 in there for the final exam grade, because that'll give me 5 grades and I'll drop the lowest to that 4 count. And so I didn't drop anything yet, because right now there's just those 4 in there. And if you don't take the final, all 4 of them will count. All right?
Yeah, but the taking it will not hurt you because they'll just get dropped.
Right. If you don't do well on it, it will not hurt you because it will get dropped.
Whether it's a 0 or an 80, if it's lowest, it gets dropped.
Right.
Okay. Thank you.
Okay. Then let's go back to where we left off. Last class, we were looking at a copy of the problem set of practice for the final, to kind of go through and remind everybody of everything that we've done thus far. If any of you weren't here on Tuesday, first question was asking if something was a function or not. And the easiest way is to recognize that that's a circle, and a circle fails the vertical line test. Otherwise, solve for y, and because we're taking the square root, we'll have a plus and minus. Next question asked us to remember that distance formula. Next question asked us to subtract fractions with the common denominator. We said we had to subtract numerators, be careful with signs. And also we said with any of these rational expression questions, if there's a variable in the denominator, we need to exclude values that make that denominator equal to 0. Next question was strictly a subtraction problem, and we had said, again, when you subtract polynomials, you have to watch your signs. Make sure you distribute that negative. Question 5 was a parabola. Because it was in that vertex form, if you recognize that vertex form, you can get the coordinates of the vertex by just looking. Then we looked at changing degrees into radians. And we had said that if there are no rounding words, we're going to leave it in terms of pi. Then there was a multiplication of rational expressions. Again, you exclude values that make that denominator equal to 0. Realize instead if it's a division, you have to set the original denominator equal to 0. And after you take the reciprocal, you have to set that new denominator equal to 0 also. Then next question asks us to complete the square and write the given equation in standard form, then find the center and radius of the circle. Oh, I guess, you know what? I am talking in run-on sentences today. I forgot to ask before we look at question 8. Does anybody have questions on anything that went on in numbers 1 through 7? Question 8, then we have x squared plus y squared minus 4x minus 6y minus 12 equals 0. I'm going to scooch this over a little bit so that I have a little bit more scrap place to work on. X squared plus y squared minus 4x minus 6y minus 12 equals 0. First thing we have to do is complete the square to write it in standard form. Does everybody remember to complete the square? You want to move that constant term over to the other side. So we'll add 12 to both sides. And then on the variable side, we just want to use a commutative property to regroup, to rearrange those terms so that the x terms are next to each other, the y terms are next to each other, and we want that constant on the other side. And then if you recall, we wanted to fill in the space with what's needed to make that a perfect square trinomial. And in order to decide what goes there, because our leading coefficient is 1 on x, we'll take half of the x, plain x coefficient and square it. So that has me add 4. And what I add to one side, I have to add to the other. And then doing the same type of work in y, when we take half of the y coefficient and square it, we get 9. So we'll also add 9 to both sides. So that gives me x squared minus 4x plus 4 plus y squared minus 6y plus 9 equals 25. To that point, is everybody okay? We did this to make these perfect square trinomials. And so by perfect square trinomial, we mean that x squared minus 4x plus 4 is a binomial square. That'll be x minus 2 squared. In the same way, this should be a perfect square trinomial. That should be y minus 3 squared, and that equals 25. And again, the number that's in this parentheses turns out to be whatever the value was that we squared when we completed the square. Now that we're in this form, our center is 2, 3, and our radius is 5, because that's that x minus h squared plus y minus k squared equals r squared. So h and k are the coordinates of the center, and r is the radius. So going back, the center of the circle was 2, 3. The standard form was x minus 2 squared plus y minus 3 squared equals 25. The radius is 5. And then to graph it, we'll go to that center, 2, 3. And in my labs, you'll use that circle tool First, you'll click on the center, and then the radius is 5. 1, 2, 3, 4, 5. We'll move 5 points out. And the circle tool will just finish the circle for you. Because I'm not using that right now, I'm going to go 5 out in each direction. And try my down disc to draw a circle. How is everybody with that type of question?
Could you show the formula for it down at the bottom there again, please?
The final one for a circle is x minus h squared plus y minus k squared equals r squared. It's actually like your distance formula if you squared both sides, because it really is the distance formula, because we're saying that the distance from the center to any point on the circle is equal to the radius. Better? Next question then makes use of what we were just looking at, changing radians to degrees. And again, the key thing you need to remember is that pi radians is equal to 180 degrees. Realize, I know some people get carried away with the idea and just say pi equals 180. It doesn't. Pi equals 3.141, whatever. But that number of radians in measurement is equivalent to 180 degrees. And so to change from radians to degrees, we've got pi over 6 radians. We want to introduce the degrees, so we're going to take that conversion fact and write it as a circle with the degrees in the numerator. Here the radians will cancel. And when I multiply that out, I will get 150 degrees. Is everybody comfortable with that one? Hearing no questions, I'm going to scroll up to the next question. Next question, we've got a complex number, something in a plus bi form, and we want to divide. We've got 2 plus 2i divided by 4 plus 3i. Can anybody remember what we have to do to divide complex numbers? I'm hoping that the deafening silence that I'm getting isn't that you don't remember, but rather you just don't feel like talking in Zoom today. Remember, what we had to do is take the conjugate of the denominator. Remember, if I have a plus bi, the conjugate is a minus bi, because when I take the product of the sum and difference, it's the first one squared minus the second one squared, which will get rid of that I, because we have to remember that I squared is equal to -1. So we're taking the conjugate of the denominator. The conjugate of 4 plus 3i is 4 minus 3i. And then with a fraction, whenever we multiply 1/2 of the fraction, either numerator or denominator, by something, we have to multiply the other part by the same thing, because we want to make sure that we're just multiplying by 1. We're not changing what it equals, just what it looks like. Let's multiply the numerator out first. You can FOIL, you can repeatedly distribute, you can box. I'm going to FOIL. First is 8, outer is minus 6i, inner is plus 8i, last would be minus 6i squared. But remember that I squared is -1. So minus 6i squared is equivalent to plus 6. So that gives me 8 plus 2i plus 6. So that numerator is 14 plus 2i. In the denominator, because it's a conjugate pair, that's going to be the first term squared minus the second term squared. 4 squared is 16 minus 3i squared would be -9, because remember that I squared is -1. And so that gives me a denominator of 25. The problem is we're not done yet, because they want us to separate it into a plus bi form, where a and b are fractions. And so we want to take the real part out. The real part would be 14 over 25. In between, we'll have a plus sign. The imaginary part will be 2 over 25 times I. Just taking that and separating it into two fractions. Does everybody recall rationalizing the denominator of a complex fraction, which is the equivalent of dividing complex numbers? Anybody need any extra help with that one? If not, next question, again, is similar to what we were just working on. So you've got a telephone pole, 60 feet tall. There's a guy wire 89 feet long that's attached to the ground at the top and the top of the pole. We want the measure of the angle in between the wire and the pole, which would be this angle up here. What's key to note here is that we've got a right angle at the bottom. We're saying that our telephone pole is perpendicular to the ground and we have level ground. In making that decision, does everybody see that what we've got here is a right triangle? And to find a missing angle of a right triangle, I'm going to use one of my trigonometric functions. And so whatever memory aid you need, the angle that we're looking for is up here. This 89 is the hypotenuse, so that means I'm not using tangent. That 60 is right next to the angle. It's the adjacent, so I'll use cosine. So I'll say that the cosine of theta is the adjacent side 60 over the hypotenuse 89. Quite literally, that's all my work. One thing I need to be careful of is this question asks for the angle to the nearest degree. So I turn on my calculator. I want to make sure that my calculator is in degree mode. Right now, mine isn't. The last question I must have done with my calculator was a radian one. So I'm switching my calculator to degrees. And then remember, to find the angle, we have to use that inverse function. And that inverse function is what comes up when we use the second or the shift key in our calculator, depending on the brand you have. So I'm going to type second cosine 60 over 89, second cosine. And again, I've got that cosine with a -1, which is that inverse cosine notation. 60 divided by 89. I'll close my parentheses and I get 47.61 degrees. They want it to the nearest degree, so to the nearest degree, it would round up to 47 degrees. Is everybody okay with that one? And that's the most recent stuff we've been working on.
Would it not be 48 or am I?
Oh, it would be 48. Thank you. Why did I read that as 46? Yeah. You're right. I apologize. I read that as 46 point something. Next question asks us to simplify an expression. Remember, when we simplify an expression, we have to use our order of operations. So I've got 9 minus 2 parentheses 5 minus parentheses 9y minus 9, close, close. Order of operations says that we want to start inside first. Those are not like terms. I can't do anything in there. So to get them out of the parentheses, this minus sign, we're going to think of as having a coefficient of -1, which we'll distribute, which gives me 9 minus 2, and that would be 5 minus 9y, and minus times minus would be plus 9. Now inside those parentheses, when we combine like terms, we'll have 9 minus 2 times 5 and 9 gives me 14 minus 9y. Now we'll distribute that 2 to get 9 minus 28 plus 18y. And so 9 minus 28 is -19. So -19 plus 18y, or most people would probably write that as 18y minus 19. They're interchangeable. Is everybody all right with that one? Not hearing any questions. Next, we have a linear equation to solve. We know it's linear because we don't have any variables. I'm sorry, any exponents written on the variables. And so they all have an exponent of 1, which makes it linear. So we're going to start with that 2 parentheses x minus 3 minus 3 parentheses x minus 2 equals x plus 2 minus parentheses x minus 4. First thing we want to do is simplify each side as much as possible. On the left, first I'll distribute that 2, getting 2x minus 6. Then I'll distribute that -3, giving me minus 3x plus 6. And so that side becomes -x. The 6's would add to 0. On the other side, first I'll distribute that -1, so that's minus x plus 4. And then the x's would add to 0, so I'm left with 6. So I've got -x equals 6. And so dividing by -1, I'll get x equals -6. Is everybody all right with that one? Looking at
Yeah,
the,
I am.
say that again?
I was just saying I'm good.
Thank you. Does everybody remember that if it's all real numbers, it means that the variable disappears and we get a true statement? And it's no solution if the variable disappears and we end up with a false statement. Next question asks us to solve a polynomial equation using the zero product principle. To use the zero product principle, the first thing that we need to do is make one side 0. And so making one side 0, I like to leave the highest degree term positive. So I'll subtract the 27x and add the 9 to both sides. And so that gives me 0 equals 3x cubed minus x squared minus 27x plus 9. For the zero product principle, after one side is 0, the next thing that we want to do is factor completely. And oh my heavens, there's 4 terms there. Does everybody remember, if there are 4 terms, we want to factor by grouping. Try factor by grouping first. So splitting that in half, the first 2 terms have a factor of x squared in common, leaving me with 3x minus 1. The second 2 terms have a factor of 9 in common. Because this first is negative, I'm going to divide out a -9, leaving me with 3x minus 1. When I factor by grouping, this is when I smile because I noticed that now they have a common factor of 3x minus 1. Taking that out, I'll have 0 equals 3x minus 1 times the other factor would be what's left when I divide that out, or the x squared minus 9. Again, I said factor completely. We can still factor this further. That becomes 3x minus 1 times, hopefully everybody recognizes that this is the difference of squares. So that'll be x plus 3 times x minus 3. And then I'm going to set each factor to 0. So that gives me 3x minus 1 equals 0. And when I solve that, I'll get x equals 1/3. That'll give me x plus 3 equals 0. When I solve that, I'll get x equals -3. And I'll also have x minus 3 equals 0. And when I solve that, I'll get x equals 3. And so I've got 3 answers: 1/3, -3, and 3. And looking back at the original equation, because it was 3rd degree, I should not be surprised that I had 3 solutions. Again, if you try to take shortcuts and you don't make one side 0 before you start solving, you might lose solutions. And again, if they say use the 0 product principle, it's kind of like telling you need that 0. Although you need it whether they tell you to use that or not. Is question 14 all right for everybody? Not hearing any questions, can we move on to 15? 15 asks me to use an identity to evaluate the expression, not to use a calculator. Well, for my identity, I notice here that I have sine and cosecant. And so what you have to remember is that cosecant is the reciprocal of sine. And so cosecant is 1/sine. So where I have sine 49 degrees times cosecant 49 degrees, that would be the sine of 49 degrees times 1/the sine of 49 degrees, which would give me the sine of 49 over the sine of 49, or anything over itself is 1. Or just recognizing the fact that in general, when I multiply something by its reciprocal, that product will always be 1. Again, though, that's the one thing with the trig. There's a lot of general relationships between those functions and definitions that you really do need to know. You need to have committed to memory. Once you recognize that fact, though, I think that's a pretty straightforward question. Does anybody have questions with that one? Does anybody want me to write out all of the trig identities for you to remember, or do you have them all written someplace already?
I'm good on that.
Okay, great, thank you for letting me know. The next one is a radical equation. On the chapter test for this, there were some people who made some careless mistakes solving those radical equations. So let me rewrite this equation up at the top so I have room to do it. I get 2x plus 15, plus 15. Then outside the radical, I have -6 equals x. On this test, I think most people remember that you had to square both sides. But before you square both sides, the first thing that you want to do is get that radical alone. You have to isolate the radical. So I have to add that 6 to both sides, which gives me then that the square root of 2x plus 15 is equal to x plus 6. If you square it without getting a radical alone, you get a mess. Because remember, if you've got 2 terms, in order to square it, you have to multiply it by itself or use that perfect square property. Now that the radical is alone, now I'm going to square both sides. On the side with the radical, when I square it, I just lift the radicand. That leaves me 2x plus 15. On the other side, you have to be careful. When I square a binomial, I get a trinomial. If you're not confident, remember that what you need to do is take that and multiply it by itself. Or using the knowledge that we developed when we focused on completing the square, remember that that's the first one squared plus twice the product plus the last one squared. Now I've got a polynomial equation with an exponent, so I'm going to use that 0 multiplication problem or make one side 0. So I'll subtract the 2x and the 15 from both sides. And that gives me 0 equals x squared plus 10x plus 21. To solve that, if you were a glutton for punishment, you try to complete the square, or you'd use a quadratic formula. Hopefully everybody recognizes the factors of 21 are 7 and 3, and they add to 10. And we can use that shortcut because our leading coefficient is 1. So x squared is x times x. 21 is 7 times 3. Signs are the same, both positive. And so setting each of those equal to 0, we get x can equal -7, and we get x can equal -3. Be careful with these, because with these, when they tell you to check, it's kind of like telling you there's a good chance that maybe one of those don't work. And so we want to check both in the original. Is everybody all right? Because I've kind of run out of space by the question if I pull things over and use this big scrap on the side with my check. And again, these checks are important. I've got the square root of 2. Well, if x is -7, let's check that one first. Plus 15 minus 6, does that equal -7? Well, that's the square root of 1 minus 6. And 1 minus 6 is definitely not -7. So we're going to reject the -7. Now let's go through and check the other solution. If x is -3, I get the square root of 2 times -3 plus 15 minus 6 equals, does it equal -3? Well, that becomes the square root of 9 minus 6, or 3 minus 6 is -3, and it checks. So our only viable solution is that -3. Again, especially if in my labs they tell you to check, there's probably a good reason to do that check. It's not always the case that you'll be rejecting one of those, but especially with these radical equations, it happens often enough that you should check. And so the solution set is just -3. Is question 16 all right? I feel like I'm moving along too quickly. Is this pacing all right for you guys, or am I moving along too quickly?
It's good for me. I've been able to follow along pretty well.
Okay, please, if I say anything too fast or you yell at me, ask me to slow down, please. Next says you're choosing between 2 health clubs. Club A offers a membership of $27 plus a monthly fee of $29. Club B offers a membership fee of $17 plus a monthly fee of $21. After how many months Will the total cost of each club be the same? And what will the total cost be? Well, we're looking for the number of months. So I'm going to let X equal the number of months. And then I'm going to come up with a function for each. For club A, it'll be A of X. And for club A, I pay $27 up front. And then every month I pay $29. So I'll take that 29 and multiply it by the number of months. For club B, let's see. Oh, our membership fee is a lot less. It's only $17, but ooh, our monthly fee is more, 31x. We're wondering, when will they be the same? Well, to find when they're the same, we'll set those two expressions equal. To solve, first I'll get all of the variables on the same side of the equation, subtracting the 29x. Gives me 27 equals 17 plus 2x. Subtracting the 17, I get 2x equals 10. So they'll be equal in dividing 5 months. And then to find the cost, after 5 months, A of 5 would be 27 plus 29 times 5 would be 27 plus 145 would be 172. B of 5 would be 17 plus 31 times 5 would be 17 plus 155 would be 172. They're the same. And that cost after 5 months, total cost would be $172. How is everybody with that one? I know there's a whole bunch of people in class that have been letting me know all semester long that you don't like word problems. Is everybody okay reading through that paragraph and realizing what we're looking for and the relationship between the variable and what we know?
Yeah, but I still hate them.
Next question then asks us to find the length of X to the nearest whole number. And with this question, we always have, in a picture like this, said that in order to use our trig, we want to break it down into right triangles. And in this picture, I have 2 right triangles, the red one and the big blue outer one. Usually with these, we know a common side and we're looking for a piece. This one's different though. This is not a full side of either. And so the trig equation that I would have to set up to solve that would get quite ugly. And when that's not a side of either, especially if you can see a relationship between those 2 angles, I'm going to find all the angles first. And so I'm going to blow that up a little bit bigger so I can scribble on it a little bit. If this angle is 50 degrees, then this angle over here would have to be 130. And if this angle over here is 25 degrees, well, wouldn't this angle up here have to be 180 minus the other 2 angles in the triangle, 130 and 25, which makes this angle also 25 degrees. And if those 2 angles are both 25 degrees, this triangle out here is isosceles. or if those two angles are same, the opposite sides are the same, so that if this side is 370, then this side must also be 370. And so now I can just focus on that little inner triangle. In that little inner triangle, we want one leg. We know the hypotenuse is 370, and we know the angle opposite that leg is 50 degrees. And so because we have opposite and hypotenuse, I'm going to use sine. So I'll say that the sine of 50 is equal to x over that side, 370. Cross multiplying, I'll get x is 370 times the sine of 50. And again, it's real important that you make note of the fact that we're in degrees. When you turn on your calculator, make sure it's still in degrees from the last question. If not, put it in degrees. Then we'll take 370 times the sine of 50. And so that gives me 283.436, rounding to the nearest whole number. Hopefully I round right this time. And I get 283. Is that question all right with everybody? With these problems with two triangles, that one is the trickiest one, where what we know is not a full side of any of the right triangles, and we have to do some other manipulations. Any questions, or anybody need any more time with that one? Not hearing any concerns, I'm going to scroll up. I'm going to make this just a little bit bigger so I have a little bit more writing room. It says use the given conditions to write the equation for a line in point, slope, and general form. With this question on this test, there were a hell of a lot of people who had the right work but didn't put in the right answer. If it asks for point slope form, your point slope form is y minus the y value of the point is equal to the slope times x minus the x value of the point. And leave it in that form if it asks for it in that form. Don't oversimplify. We wanted to go through this point, so this will be my x1, y1. And then parallel, we have to remember that if lines are parallel, it means that they'll have the same slope. And so in order to find the slope of this line, to find the slope, we're going to solve for y. So that gives me 7x minus 4 is equal to 9y. And dividing, I'll have 7 9x minus 4 9 equals y. So in this one, the slope is the x coefficient, 7 9. So for my point slope form, I'll have y minus the y value, 3, is equal to the slope, 7 9 times x minus the x value, which is -8. And that I will simplify. Subtracting a negative is like adding a positive. And so for this answer, when they want it in point slope form, stop there. Y minus 3 is equal to 7 9 times x plus 8. Then, in general form, one side is 0. To make that one side 0, Let's see, I could distribute y minus 3 is equal to 7/9 x plus 7/9 times 8 would be 56/9. The fractions with the denominator of 9 aren't fun, so I'm going to multiply both sides by that denominator 9 and get 9y minus 27 equals 7x plus 56. I'll make the right 0, subtracting the 9y will give me 7x minus 9y. Adding the 27 to the 56 will make it plus 83. So my general equation is 7x minus 9y plus 83 equals 0. Usually the only ones where they're asking you to put them into that general form are either the parallel or the perpendicular ones. And so let's notice something. Because I know that this line has to be parallel, you see how this one starts with 7x minus 9y? General form of the other one, if I clear my fraction, should also start with that 7x minus 9y. All that because the x and y coefficients are what determines the slope in lines. All that would change would be that constant term. Does everybody remember these? Again, there was a heck of a lot of people who on this line for point slope form would give me a y equals mx plus b. Y equals mx plus b is slope intercept form, which is different than point slope form. This, folks, is the point slope form. Have I said that often enough in this question? How's everybody with number 19? A little bit of a blast from the past. Then going on to number 20, we're asked to find the side of a right triangle with given information. We're looking for side A. Well, because it's a right triangle, we're going to use our trig. Again, if you need to put a memory aid down there, do so. In this right triangle, I know one leg, and I'm looking for the other leg. The hypotenuse doesn't fall into place. So I'm going to use the only one that doesn't involve the hypotenuse, which is tangent. And so the tangent of my angle, and please remember that it's in degrees. We're going to need our calculators in degrees. Tangent is opposite, which is little a, over adjacent, which is 360. If I think of this being over 1, when I cross multiply, I get a equals 360 times the tangent of 39 degrees. And again, I don't remember how much I belabored this point when we were first looking at trig. When I multiplied that trig function by that constant, I like to make sure I put that constant out in front, because sometimes you get people making careless mistakes, multiplying the side by the angle measured and not its function. So put that coefficient out in front of the function. So now I'm going to just make sure I'm in degrees, and then take 360 times the tangent of 39, and that gives me 291.5222, and it keeps on going to the nearest whole number. That would round up to 292. Is everybody all right with that one? Not hearing any questions. Let's go on and look at the next one. The next one gives me a dot graph of a function, and it asks me to find the domain, the range, the x-intercepts, if there are any, the y-intercept is there, if there is any, and the function value below. I took the liberty before I even started looking at this of making it bigger because I've got small eyes and it was tough for me to read it originally. When this is in my labs, you can click on that magnifying glass to make it larger. Because I changed it into a PDF to put it in your notes, I didn't have that option. Does everybody remember that the domain would be the set of the x values? And so if I take this picture and compare it to the x-axis, comparing it to the x-axis, the smallest value is -3, and the largest x value is 0. We're asked to put them in interval notation. Without interval notation, this would be -3 is strictly less than x is less than or equal to 0, because again, open dot means it can't be equal. Open dot is like a rounded parentheses. Closed dot means it can be equal. Closed dot is like a squared parentheses. Then next thing that we're looking for is the range. The range is a similar idea, but instead I want to compare it to the y-axis. The range are my y values. And so when I compare this thing to the y-axis, the lowest value is -4. The highest value is 5. So my y values go from -4 to 5. -4 is that closed dot, so it's my squared parentheses. 5 is by that open dot, so it's my rounded. X-intercept is where I cross the x-axis. And so I cross that x-axis at -2. And I have to apologize. I think whenever we did these in class, we wrote that as a point. We wrote that as the point -2, 0. However, if we look at the specific directions in this question, they want you to just type a single answer, not an ordered pair. So we'll just put in that -2. The y-intercept is where I cross the y-axis. And here I cross the y-axis at -4. And again, while we can think of that as a point, the point is 0, -4, they just want the single integer. Then, lastly, they ask us to find f of -1. Well, to find f of -1, we have to remember that f of x is equal to y. And so what this question is asking me is, when x equals -1, what's the corresponding y value? So when x is -1, the corresponding y value is 4. So we'll say that, I'm sorry, it's -4. Down below, no, I take that back. It's not -4. 1, 2, 3, it's -3. And so f of -1 is -3. You've got glasses, wear glasses when you read those graphs. -1, -2, -3. Is everybody comfortable with that one? Again, remember, open dot is like the soft parentheses, means it can't equal. Closed dot is like the squared parentheses, means it can equal. Remember that the domain are the x values, the range are the y values. If I'm looking for f of a number, they're saying x is equal to that number. What's the corresponding y value? Okay. Then moving on. Next one asks me to use my calculator to find the value of the trig function. The only thing that's tricky here, because this is mostly a calculator question, the only thing that's tricky here Because we have to realize that, whoops, I have to apologize. I think this is the last class where I'm giving notes, writing on the tablet in my stylus is just went on strike. It's not letting me write. So let me pull the battery out and see if I can rub it on some fabric and coax a little bit of extra life out of it. Yeah, we did. What we have to recognize is that that is in radian measure because there is no degrees. And so this is where we want to take our calculator and change it from degrees into radians. And now that we have radians, we're just going to type in the cosine of 6 pi over 17. Again, to avoid rounding, make sure you use the pi key on your calculator. And so the cosine is 6 pi over 17. On my calculator gives me 0.445738356, rounding to the nearest 4 decimal places. Because this is a 3, we'll round down, gives me 0.4457. Next one, again, the hardest part for most people is understanding what the directions are asking us for. They want us to have a line in point slope form. Point slope form, again, is y minus the y value is equal to the slope times x minus the x value. Then later, the slope intercept form is y equals mx plus b. I think some of you in high school only used that latter form, and so that's what you put in. But no, this first one asks for the point slope form. We've got the slope, m is -2. We've got the point, its x value is -2. And hey, somebody went crazy with -2, its y value is -2 also. So substituting in y minus -2 would become y plus 2 is equal to my slope, -2, times x minus the x value is -2, minus a negative becomes plus. Stop there. That's your point slope form. Y plus 2 equals -2 times x plus 2. Now for the slope intercept form, we'll have to take this and solve for y. So first let's simplify. Y plus 2 is equal to -2x minus 4. And then subtracting, I get y equals -2x minus 6. And that's the slope intercept form. And please remember with the slope intercept form, that intercept that we're talking about is the y-intercept. That question, all right. Then going on, we have a division problem, division with rational expressions. Because I have variables in the denominator, I've got to exclude things. Again, we exclude where the denominator is equal to 0. So the first denominator is 9x minus 9. When we set that equal to 0, solving, we get 9x equals 9, or x equals 1. And since x equals 1 gives me a 0 in the denominator, x can't be 1. Next denominator is x squared plus 3x minus 4. When I set that equal to 0, I've got a quadratic. And again, you have choices of solving, but I think that's an easy factor. X plus 4, x minus 1 equals 0. Setting the x plus 4 equals 0, I get x equals -4. And setting the x minus 1 equals 0, I get x equals 1, which we've already dealt with. Everybody all right with that part? Then the next thing we have to remember is the rule for division is you don't divide. You change it into a multiplication problem, but in order to do that, we're going to keep that first fraction the same. We're going to change our division to multiplication. And after I change the division to multiplication, I have to take the reciprocal of that second fraction, or I have to interchange the numerator and denominator. Uh-oh. In doing that, we've got a new denominator. And that denominator can't be 0 either. So that gives me x squared plus 8x plus 16 equals 0. That factors into x plus 4 times x plus 4 equals 0. And so this time when I solve those, I get x equals -4, which is a value we already considered. Sometimes that's the case, but other times it's not. So please be careful. If I'm doing a division, when I'm looking for values to exclude, I have to remember that new denominator that I get when I take the reciprocal. Now, hopefully everybody remembers that we did rational expressions right after we factored, because next step is to factor. Factoring completely, that first numerator is the difference of squares, so that'll be x minus 4 times x plus 4. That denominator has a common factor of 9, leaving me with x minus 1. That second numerator we factored already. That's x plus 4 times x minus 1. And that second denominator we also factored already. That's x plus 4 times x plus 4. And now, the way we multiply fractions is we multiply straight across. So I now think of this as one great big fraction. And I'm wondering, can I simplify? Is there anything common to the numerator and the denominator? They both have x factor of x minus 1. We both have a factor of x plus 4 and a second factor of x plus 4. Again, remember, we're only dividing out complete factors. When I do that, what I have left is just that x minus 4 over 9. So again, I like to say fractions are fun if you factor first, factor, 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 factor. But rewrite that division as a multiplication first. And remember, when it asks what to exclude, we're looking for values that make any denominator equal to 0. So for that idea of excluding, I have to look at every possible denominator. Is that one all right? Not hearing any concerns. Next, we've got a compound inequality. And I know that there were some people that when they solved the compound inequality, they split it into two separate inequalities, which you can do, but I'm kind of lazy. So I try to do it all at once. And I want to get x alone in the middle. And so where I have -2 is less than or equal to 2/3 x plus 4 is less than 6. And trying to isolate the x to get it alone, first I'll move that constant term or subtract 4 from all three parts. Here on the left, I'll get -6. In the middle, I'll have 2/3 x. And on the right, I'll have 2. Because we're adding or subtracting, our inequality stays the same. It only reverses when we multiply or divide by a negative. Now, in order to get the x all alone in the middle, I have to move that coefficient 2/3. You can divide by 2/3, but again, dividing by a fraction, I think, is easiest shown if we multiply by the reciprocal. And again, with a compound inequality, whatever I do to one part, I have to do to all three parts. So that gives me -9 is less than or equal to x is less than 3. Again, remember, because what we're multiplying by is positive, our inequalities stay in the same direction. So the smallest value is -9 because they want interval notation. The largest value is 3. I can equal the -9. I cannot equal the 3. So it'll be closed at -9 and open at 3. That one, all right. Then last one, we're asked to evaluate the algebraic expression for the given values. So first thing we want to do is substitute those numbers for the values. So x is 8. Whenever I substitute in something and the variable has an exponent, I put parentheses around it. Some of you that don't put those parentheses around are kind of prone to sign errors. Make sure when you substitute a value, especially if it's negative, you want to put parentheses around it. Now we've got -6 times in parentheses, x is 8, minus y is 2. Now order of operations, first we do what's inside the parentheses. So that gives me 8 squared minus 6 times 6. Then exponent 64 minus 6 times 6. Then remember, we multiply before we subtract. So that's 64 minus 36. And that difference gives me 28. And I know way back at the beginning of the semester, for some of you folks, problems like that, remembering your order of operations, seem a bit involved. Hopefully with everything that we've learned over the course of the semester, or relearned for those of you who took this class as a review, that seems a lot easier than it did at the beginning of the semester. And folks, that's the last question. After that, well, I didn't even insert the answers. I thought I did. So if your final exam is very similar to these 26 questions, how will you do? I know some of you missed a test. If you missed a test, it's imperative that you take the final exam so that you get that 0 out of your average. Does anybody have questions on any of those problems?
Will this note, like for this class, will this note thing will be available by tomorrow or by today by any chance, do you know?
It should be, although I have to tell you, yesterday when I tried to download my notes for the class, OneNote didn't play nicely with me. It keeps asking, when I try to save something, OneNote keeps asking me for a product key, which I don't have. And so with the classes that I taught yesterday, I was unable to upload the written word, but I was able to upload the YouTube video. So depending on whether OneNote likes me or not, depends on whether we'll have both the written word and the video or not. So
Okay, cool. Thank you so much, Sarah. I was like, I'm not sure if it was up yet because of the video. I was like, I don't know if I should, ask her or not. But no, thank you. I appreciate it.
Okay, so I know that those first few were uploaded with the notes from Thursday. But the rest of them, if it lets me save them, I will. But if it doesn't, I can't. So, oh my heavens, every time I tried to save, export the OneNote as a PDF, it immediately, the computer would freeze. I don't know why.
Oh,
I don't
okay.
know if I've got over the course of the semester too much saved on there or what. I just don't know. So.
Gotcha. All right. Well, no, thank you. I appreciate it. I was just wondering if I should ask. I was like, should I ask her? Or
Yeah, no, and honestly, I want to say that if you ever looked for the notes over the course of the semester and they weren't there, just, shoot me an email because I save them and it's just a matter of, actually, especially with the videos, sometimes YouTube takes about a half an hour to upload the video because my internet is so crappy. And sometimes I think it's all there and it isn't. So if there had been a problem, I hope you felt comfortable letting me know. I guess it's a little bit
Oh, of
late
course.
for us to say that.
A little bit.
Yeah.
No, there was one time I was like, I don't know if this is right because like my thing was glitching for some reason. So I was
Mhm.
like, I should probably tell her, but then I think it was just my computer. But no, everything has been so far amazing. Thank you for all your help. I really do appreciate it.
Okay, well, thank you. Does anybody have questions on anything?
I'm good. Thank you.
Good. Well, if you guys are all right, it's a half hour early, but we can call it a day. I have to tell you guys, this is the last Zoom class that I'm actually teaching. Thank you, all of you who have been coming regularly. I think looking through the grade book, your grade reflects the effort that you've put in, and I appreciate your attendance. I'm sorry, the one thing I hate about Zoom teaching is that there's much less of a discussion between me and you guys. And I think it's because you're, I don't know if you're afraid to interrupt or not. I know in an in-person class, when I ask those open-ended questions, people usually respond and it's much more a discussion than a lecture. I hate kind of just lecturing, but I guess in Zoom, it's difficult to do otherwise. So if there's anything I can do for you, please, please, please let me know. Feel free. I will be available during class time on Thursday, but don't feel like you have to attend. I am not taking attendance. Again, if your life is real close for time, while I'm giving you 2.5 hours for the final, I think you should be able to finish it in 2 hours so that at least you have the regular class time block of time in which to take it. So anybody want to go over anything else or do anything else, or shall we call it a day?
Yeah, I feel like I'm all set.
I'm all good too. This is Terrell, I have a question. My one friend said you were retiring this semester. Is that true?
Yep. This is my last
No!
Zoom class ever.
No.
My first full-time teaching job, believe it or not, was in 1982. And while I haven't been, this is my 14th year at the college, I've kind of been teaching since 1982, except I think I took about 3 years off from teaching when my children were very little. And then I started going back to work as part-time as an adjunct at ECC. But
Gotcha.
so I've been doing this for kind of a long time. And I enjoy, I hope you guys get the impression I like math, and I really do enjoy working with students, but my husband retired 8 years ago and my kids started having kids. And so all of a sudden I want to be spending all that time with my family again. So yeah.
As you should. That's so cute. I was just wondering. I'm like, I'm not sure if if I should ask this, but I was like, that's so sad. Oh my gosh. You're really one of the best math teachers I've had so far since high school. So I really do appreciate it.
Oh, thank you so much. So it's been fun teaching you guys, but it's I think I've been around long enough. It's time for some younger folks to move on in. So yeah.
True.
Well, congratulations
Alright.
and thanks for the semester.
Okay, thank you guys for being so great. And hopefully you got something out of it. Hopefully you learned something. Even those of you who might have seen this content before, hopefully it was enough of a nudge to your memory. So, because most people take this as a prerequisite for something, whether it's something that you need in your program or something that you need in your next math class. Hopefully you're a little bit more confident about this stuff. So, all right, well, have a great day, you guys. And make sure when you do the finals in my labs, make sure you do the problem set first. It counts as a quiz grade. Make sure you do the final. It's in my labs. Make sure you submit your work. And not with the final exam, but with the class yesterday, I had a problem that arose with one of my students in their last chapter test. They finished the test in Blackboard. With you guys, it would be in my labs. There's a timestamp there, and they did not submit the work to me until 4 hours later. And that makes me think that something might have been going on that makes me think I should, there might have been some cheating involved. And so please, 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 as soon as you finish that test, submit that work. Don't wait hours and hours and hours and hours, because it does look really, really suspicious. And I hate doubting your integrity, because you guys have been great so far. Okay? So, all right, have fun with that final if you're taking it. If you're not taking it, congratulations on doing well enough on the semester that you don't feel the need to. I'm not going to ask you folks to tell me, but I'm not going to play mother hen. If somebody doesn't take the final, I'm not going to go chase an after shoe. I'm going to go on the assumption that that was a conscientious decision on your part. Okay? All right, have a good one, you guys.
Thank you.
Thank you so much.
All
I
right, thank you.
really
Take care.
appreciate
You too. Bye-bye.
it. Stay safe.